Hello everyone, welcome back to a new tutorial. Today you will learn everything you need about dependency injection. So without further ado, let's jump right in. So first of all, what is dependency injection anyway? Dependency injection is a technique to handle classes that requires other classes in order to function correctly. For example, the class computer might need a reference to a class component. The class reference component is what we call dependency. In other words, the class computer depends on component reference in order to function properly. We can provide the needed dependencies by providing it to constructor. For example, the class computer would create an instance of a component class. We can obtain the dependency using a dedicated getter, injecting as a parameter. For example, the class computer would have in parameter component class. In this case, we call this approach dependency injection. The benefits of a dependency injection or using the dependency injection pattern, we will have a reusable code, which means that we can use a different part of the code in a different section of our project, easily refactoring the code, so our code can be maintainable. And the last one, which is the ease of testing our code, so our code will be testable. There are two approaches of dependency injection pattern. The first one, which is constructor injection. You inject dependencies in the constructor as shown in the previous example. The second one, which is field injection. Sometimes it's not possible to inject dependencies in constructor. For example, some dependencies are instantiated by Android system, such as activities. In this case, we proceed with field injection. In other words, all the dependencies will be instantiated after the class is created. This will lead us to talk about manual dependency injection. So, as clean architecture is the recommended architecture, you will have a project structured like this. So let's come back to the Android Studio, and inside the parent package, I'm going to create a basic structure of a clean architecture project. First layer, it's going to be data layer, and the other layer, which is domain layer. For this particular example, I'm not going to use the implementation or the interface inside the domain layer. I'm just going to create the structure of a clean architecture. And the last one, which is the presentation layer, I'm not going to create it, of course, because we have UI as a presentation layer. So inside the data layer, I'm going to create another layer, which is remote package. And you may have inside your data layer a package for your local database. I'm going to call it local. And the last one will be the repository. Basically, the repository, it consists of the implementation of the domain layer. For simplicity purposes, I'm going to assume that the class inside this layer, which is repository, will be the implementation of another class that we have coded in our domain layer. So I'm going to call here repository. And for the domain layer, of course, you will have the model package and the other layer, which is repository. It consists of the definition of the methods and the interfaces that we will use in our projects. So here I'm going to call it repository again. So this is a basic structure of a clean architecture project. So imagine that you have here, for example, inside the local package, let's create, for example, another class. It's going to be called database, or let's call it product database. Let's assume this product database is a database class of type room database. So we have to construct product database, and this is a dependency. Just keep that in mind. For the remote package, let's assume that you want to work with retrofits. So you have to create here an interface. Let's call it product API. It's going to be an interface, and this is for retrofits. And finally, for the implementation of the repository, I'm going to create here a simple class, and I'm going to call it product repository. I'm not going to add here implementation. I'm assuming this product repository is the implementation of another class that we have coded before. So it's going to be product repository. I'm going to hit enter, and this repository will have two dependencies. So the first one, we need, of course, an instance of the API of type product API and another constructor or another instance, which is database. I'm gonna call it product of type, of course, product database. And here it's gonna be the rest of the code. So this is the first layer that you have to code, and the other section, which is the part of model or the view model inside our presentation layer. So you might have here something called product view model, and as a dependency, we need the repository. So the repository will be a private val repository of type product repository. So this is a dependency. Everything here is fine. So now let's assume that we want to work with this view model. Just for testing purposes, I'm going to add here a mutable state flow, and I will add here products, and it's going to be a list of products model. I'm going to create here inside the model just a dummy class. It's going to be called product. It will have only val ID of type it's to integer, and private val price of type double. Let's assume that this is the model that you want to work with or to expose to your view model. It's going to be here empty list, init val, init here, and we will do products dot value equal empty or list of. So the first instance will be product ID equal, for example, this number, and price will be 299.99. Going to add just two elements here, product with this ID and 399. Okay, so let's come back to the main view, main activity. First of all, we have to create, of course, the product view model. Before on create, I'm going to do here private late init var, and I'm going to construct the view model. So we have to instantiate the products view model after creating our composable. I'm going to get rid of this composable, and I'm going to create here a simple composable. It's going to show us a message, and the message as a parameter of type string. Good. Now here I'm going to do colon modifier equal modifier fill max size, and it's going to be scrollable, and let's give a padding of vertically 10 dB. We have created the product view model. Now we have to instantiate the products view model. So how to do it? So after on create, here I'm going to do product view model equal product view model, and we have to provide the dependencies. So we have a dependency called repository. So this is the dependency that we have to inject. And for the record, what we are doing right now is what we call constructor injection. So we are injecting the reference of repository inside the constructor of the products view model. So let's come back to the products view model, and we have to create here val repository of type product repository. And of course, the product repository needs other dependencies. So let's come back. We have to provide the API, and we have to provide the product database. Let's assume that this interface is for retrofit. So we have to construct retrofit. So if you want to do that, I'm going to import here some dependencies for retrofits, and of course for database, in order to show the example correctly. So I'm going to import Kotlin caps here. So I'm going to add here Roam database. I'm going to change this to 1.9, and I'm going to open the build that's Gradle here. I'm going to add the Roam database version. All right, after hitting sync, we have the project ready to use retrofit and Roam database. Let's come back to the local package product database. So I'm going to add here abstract class. It will inherit from Roam database, and here the rest of the implementation. And I have to annotate this class with database. So for the version, it will be 1. And for the entities, let's write here a dummy entity. Let's call it product entity. So that's pretty much it. And let's come back to the main activity. So the first dependency in our products repository, we have to provide the API implementation or to construct the retrofit instance. I'm gonna call it here val API equal retrofit, and I will import retrofit first, and I will do here builder base URL and build, then create. We have to create the product API class.java. So this is the first dependency. The other dependency will be the database. So db equal room dot database builder, and we can access here the application from the getter and product database class.java. Let's give it a name of database, and of course here I'm going to do build. So here instead of colon I have to do here equal. So the first dependency will be API of type API, which is the API, and the database will be the database. Database, all right, or DB we have called it. Then we will do here repository. So now we have provided the needed dependency. Finally, we will do inside the set content value products by products view model dot products, and we will do here collect as state. So we can do here finally the I message products quantity is all right. So let's see if our application is running correctly. So we will have the products quantity is 2 because we have 2 quantities. So just the takeaway from this experiment, look at our code. So let's take a look at our code. We have to instantiate, first of all, the view model. We have to create the instance of API manually. We have to create the instance of database manually. We have to create an instance of repository, and we have to provide the repository as dependency to the products view model. Then we can do this task. Imagine that we have multiple operations and multiple dependencies to provide, and multiple view models as well. So all this, all the steps, we have to do it over and over again, which is not productive and it's time consuming. Thus, it's very complicated task to link between different layers while working with clean architecture projects. So that's why we have to come up with something that's gonna make our life easier. So as a solution to the previous issue, we will create a class called app container that will get the dependencies. Any needed dependency will be public. Hence, we need only the repository. It's the only public member. So I'm going to create here a new package. I'm going to call it manual. Create a new class. I'm going to call it app container. So the app container is going to allow us to manage the dependencies that we need, aka the API and the repository and the database. So the app container, here I will need a private val database equal room database builder, and we will code, of course, the same thing that as we did before. We have to provide a context as a parameter. We're going to fix it afterward, and the class representing the database, it's product to database, and the name is going to be database. And finally, we will do here build. The other dependency, I'm just going to remove here private first of all, and the other dependency, which is database, it's API, with the same thing. It's going to be retrofit dot builder and base URL, and here I'm going to do build and create. And this is the product API belongs to retrofit implementation. So product API dot class Java. Okay. So we have here to provide as a dependency of our app container context of type context. Hence the app container is needed throughout the application, we have to put it in a place that will be accessible by all activities or all fragments or all views, generally speaking. We will put it in an application class as follow. So first of all, it will inherit from the application class, and inside the application class, we will need, of course, a context. So I'm going to do here private late init var context. I will need here the app container. So late init var, it's going to be a public member. What we said before. It's going to be the only public member in order to be accessible throughout our entire application. We need here to construct or to inject the context. So in order to do that, we're going to override the method on create. So after creating the class application with app container, we have to put here or to instantiate the context. It will be application context from the getter application context. And we will instantiate the app container as follow, app container, and we have to provide the dependency context. It will be the context. So now we have the application container ready to go. We have to use it inside our manifest. So here name, and it will be application. I have to move the application with app container inside a package. I'm going to call it here. Sorry, I forgot. Application, and I'm going to move this class inside the application package refactor, and that's pretty much it. So in the main activity, here I'm going to create private member. It's going to private late init var app container, and wherever you like. Here, let's say here after instantiating the repository, I'm going to do app container equal application as application with app container, and I will be able to access the app container. Good. So from the app container, I can do here, instead of doing the whole thing, so I'm going to comment all of this because I don't need it actually, or I can get rid of all of this. And instead of this repository, I will do products repository, and I will do here API equal app container dot API and database app container dot database. So our code is cleaner. I'm going to get rid of all the unused imports, and let's run the application and see if everything is working correctly. So we have the same thing as we have done before. In case our view model is needed in more than one class, we have to create for it a factory class to allow the creation of our view model. So we will proceed as follow. So inside the manual package, I'm going to create here a new interface. I'm going to call it factory, or you can call it view model factory. So the view model factory, it will have generic type of type T, referring to the view model, and only one function to implement, which is create. It will give us, of course, the needed view model. This is the first step. The second step, inside the manual, we're going to create a new class that's going to implement this view model factory. I'm going to call it product view model factory. So inside the product view model factory, we have to implement the class view model factory, and of course of type product view model. So let's implement the needed method, which is create. Inside create, we will do return, because we have to return an instance of type product view model. So it will be product view model, and we have to provide here the repository. So as a dependency of the class product view model, we have to provide the private val product repository of type product repository, and we will give it to the as a dependency of inside the constructor product view model. So here I'm going to do product repository. Finally, inside the app container, we will create here another dependency or another instance of type product repository. It's going to be product repository, the database or the API as a first dependency that we have created, and the database as a dependency as well. And finally, it's going to be the only public member, which is product view model factory. So let's transform this to private. Why we have switched the visibility of database and API to private because we don't need to access the database and API outside the app container. We only need the product view model factory. So here I'm going to do val. Even this one, it has to be private. The public member product view model. It will be product view model factory. And the only dependency, which is the repository that we have created right now, which is product repository. Good. Now let's come back to the main activity. We have to make a couple of changes here. So in order to construct the product view model, we will get rid of this implementation, and we will do, of course, we will use the app container. So app container, that's product view model factory, that's create. So here we have the product view model provided by the factory pattern. So I'm going to run just for testing purposes the application, and let's see. Of course, it has to give us the same result. So this is the third approach in order to manage dependencies. So the strategy is an okay one, but not ideal. We still have to manage the container with its internal dependencies. As you noticed, you have a lot of boilerplates to deal with. We have to create and we have to follow some steps. As the application grows, you will have more flows to deal with. So that's why we have to look for another way to make our dependency injection mechanism automatic and to get rid of boilerplates. This is the main objective behind using Hilt. Hilt is, of course, a dependency injection library built in top of Dagger that has the sole purpose of reducing boilerplates when dealing with manual dependency injection. First of all, how to install and to prepare your product to use Hilt. We have to add in our build as Gradle, the project here. I'm going to add the implementation or the class path. This is the first step. Let's move to the build that's Gradle module file. So I'm going to add this plugin. Afterwards, we have to add these two implementations. And finally, we will add the correct error type to true. All right, so after doing that, we'll hit sync. Every application that uses Hilt must have an application class annotated with Hilt Android application. So let's move to the application class or application package. I'm going to create here a new class. I'm going to call it Hilt application. You can call it actually whatever you like, depends on the name of your project. This class has, of course, to inherit from the application class, and we have to annotate this class with a special annotation provided by Hilt called Hilt annotation or Hilt Android application. When annotating class with Hilt Android application, this will trigger Hilt to generate the necessary code as of instance base class for dependency container. The application class is the parent component. This will allow other components to access the provided dependencies. We have to annotate the main activity with the annotation Android Entry point. So let's go to the main activity. Here at the top of our class, I'm going to add Android Entry points. So when annotating the main activity with Android Entry point, it will allow Hilt to provide dependencies to class using this annotation entry point. So this is the main entrance of our dependencies. So here we can inject right now dependencies without a problem. So the supported classes are application and view model, activity, fragment, view, service like a Firebase, and broadcast receiver. So bindings contain the necessary information to provide instance of a type as a dependency. When using the annotation at inject on the class constructor, we'll tell Hilt how to provide instance of that particular class. For example, I'm going to add here another class. I'm going to call it API Builder. So once using inject annotation constructor, what does this mean? This will tell Hilt how to provide the instance of this particular class, which is API Builder. So now we are showing Hilt how to provide this the instance of API Builder. Inside, of course, we don't have actually to implement this function or this class. This is just for the sake of this tutorial. So the rest of code here. Let's say, for example, the API builder depends on another class, which I'm going to create later, Authenticator. Just for the sake of this example, another class called Authenticator. So here we have, of course, to show Hilt how to provide this dependency by adding injects. So the rest of code here. And let's come back to the API builder. It's gonna be API or authentication, of course, not authenticator. Of course, now we are showing to Hilt how to provide this dependency, which is authenticator, in the constructor of API builder. The dependency in this class is authenticator of type authentication. So under the hood, what's happened when using the inject annotation, Hilt will generate classes used at runtime to create objects for dependencies at build time. Whenever we are dealing with interfaces or a third-party library as dependencies, we need to create a module to tell Hilt how to provide dependency. So let's create here another package. I'm going to call it DI. And inside the DI package, I'm going to create an object. I'm going to call it app module. You can call it whatever you like. So in order to make this object app module a module that Hilt will detect, we have to annotate it with module. Next, we have to specify where to install the dependencies. So the install in annotation will show Hilt which class uses that dependency or install in. So for the lifetime of the dependency, we have used here in this example the singleton component. The singleton component, which is the parent class, it's created when call it the onCreate on the application class, and it is destroyed when the application is destroyed. So once using app module with the singleton install and singleton components class, as long as the application is alive, the dependencies are available. The other one, which is activity retain component, is created at when calling the activity on create and destroyed when the activity is destroyed. You can see here in this table the lifetime of each generated component. Let's say, for example, service component is created when the service is created and destroyed when the service is destroyed. So to show Hilt how to provide a dependency, we have to use the annotation provides. So the annotation provides will give Hilt the following bindings. It will give the return type. It will give the function parameters indicating to Hilt the needed dependency of the return type of the function. And it will indicate to Hilt that Hilt has to execute the body of the function every time we need the dependency. So let's say, for example, we need the dependency of products API. We will do here provides. We have to import provides. And after provides, we will write here a function that's going to allow us to provide the needed dependency. So just name it whatever you like. I'm gonna name it provides product API. So we have to give the return type of the function product API, and for the core of the function, it has to return. So as we have done before here in the app container, how we construct the API instance, we will do retrofit builder. We will write here our base URL build, and lastly, it's going to be create our instance of retrofit. So now we are showing Hilt how to provide the dependency products API. So we can inject it wherever we want. But we have to annotate this provides or this function with another annotation, which is singleton. When annotating the provides products API with singleton, this will indicate to Hilt that this dependency will be instantiated only once. So whenever the module is alive, this instantiation will happen only once in our program or in our code. So I'm going to show you another way how to provide dependencies by using the annotation binds. So what does it mean, binds annotation? It's explaining to Hilt the needed implementation to create an instance of a dependency, such as interface or third-party library. It will give the following bindings: the return type of that dependency and the parameters of the function to create other implementation to provide. So this won't be used, of course, in this objects app module. Let's create class here. I'm gonna call it product repository module. It's gonna be an abstract class. And as we did before in the objects app module, we have to annotate this class with module to indicate to Hilt this is a module. And we have to show to Hilt where to install the dependencies to manage the lifetime or the life cycle of the generated component. Install. For this particular example, I'm going to choose singleton component. And I have to show to Hilt how to provide the dependency. So in order to give a practical example, let's move to the domain layer. And here I'm going to write another an interface. So this is the second way to implement, of course, the domain layer. This is the proper way, of course, to do it. So I have to create here a product repository. Let's do it suspending function get product by ID, and it will give us a product. All right, so let's come back to the product repository. So I'm going to get rid of everything and I will rename it to implementation. So this is the implementation of the repository interface. So product repository. We need dependencies here as follows. So inject, constructor, API, and another dependency, which is database. And let's do, for example, here delay with 500, or okay, that's enough, 500 milliseconds, and we will return product. So now we have our product implementation ready to go. Let's move back to the products view model. And what we have here to inject, we have to inject the product, not the implementation, but we have to inject the products repository interface. So how to do it? Let's come back to our product repository module, and we have to show Hilt how to provide the needed dependency. So I'm going to use the binds annotation. So as a reminder, the annotation binds will explain to Hilt the needed implementation to create an instance of the dependency, such as the interface that we have talked about, which is product repository interface under the domain layer in the repository package, or a third-party library. It will give the bindings as follow: the return type and the parameters of the function to indicate to Hilt the implementation to provide. So showing Hilt this implementation or this instance will be instantiated just once with the annotation singleton. And here, as we did before in the app module, we will write let's explain to Hilt the function, but here don't forget to add abstract function. And I'm going to call it whatever you like, binds, for example, product repository. First of all, the parameter, we will need, of course, one parameter, which is repository of type, of course, product repository implementation. So instead of implementation, I'm going to add here repository, and the return type will be the product repository interface. So now we have shown Hilt or explained to Hilt how to provide this interface. So now we are able to use it in our product view model. So let's come back to our product view model. First of all, we have to annotate this class with Hilt view model. We have to provide here inject in constructor, and the dependency that we have talked about here, which is the repository interface. So private val repository, it's gonna be repository. We can do here, instead of this line, we will do view model scope dot launch, and we can do product. So here, instead of product, I'm going to change it to product. Same thing here, and it's not gonna be a list, of course. I'm going to come back to the product here, and I will add a companion object. I'm gonna call it imp function empty product. It will return product with ID equals 0 and price equals 0. and I will add here the return type product 0.0. And inside the view model, I will do here empty product dot empty, or we can just name it empty. So it's gonna be more readable. Here instead of list, it has to be, of course, without list. All right. So the value of this product, it will be the repository that we have created before dot get product, and it's to, for example, the ID equal. So inside the implementation, I will do here ID. So here I'm going to do, that's it. And inside our main activity, of course, we have to change some stuff here. We don't need the app container. I'm going to get rid of the app container with everything that has to do with manual dependency injection with the product as well. And here I'm going to do private val product view model by view models of type product view model. All right, and finally I'm going to create an observable here, val products, and finally we can do here the product is. We can override the function toString if you would like, but let's just do it quickly inside the model. Here I'm going to override the function toString. It will return ID with ID and with price. So we can do here finally inside the main activity. So simple as that. Let's okay, don't forget to change the application with Hilt application error manifest. Otherwise, it's gonna prompt an error. So before running the application, I'm going to make a small change inside the repository implementation. I'm going to get rid of the database. So why I got rid of the database dependency? Because in our app module, we didn't show Hilt how to provide this dependency. I'm going to provide it afterwards. And even in our product repository module, we didn't provide it as well here. So we don't have to put it here in the repository implementation because Hilt won't know how to inject it anyway. So I'm going to comment it. Let's run the application. So everything is working correctly. The ID is with price 768 point something like that. Good. So this is the first step, or this is the steps basically how to deal with injecting dependencies using Hilt. Sometimes we need to provide different implementation of the same type. Thus, we need to add a qualifier to distinguish between each implementation. So we have to follow basically those steps. I'm going to create for this purpose some different implementations of the same class. So inside the domain layer, I'm going to create in the repository a new interface. I'm going to call it payments. So the payment repository, it will have only one function. It's going to be suspending function, confirm. Let's assume in your application, you need to provide, or you need to implement two methods, let's say for the payment methods, or you have two payment methods that you have to explicitly write or code for it separate implementation. So let's create the first implementation. Let's call it payment repository, first implementation. Of course, we have to add here inject constructor, and it will inherit, or it has to implement the payment repository. So this is the first implementation. So for the sake of this tutorial, I'm going to write a silly message here. So I'm going to delay the function with 1.5 seconds, and it will return this, let's say this string first implementation. Let's write another one. It's gonna be the second one, and with the same thing, inject constructor, because we want to inject this class. We have to show Hilt how to provide it, and payments repository, and we have to implement again the second method. So in the second method, we're going to distinguish between the two implementations. The first one is going to be delayed with 1.5 seconds, and the second will be delayed with 2 seconds, and it will give us second implementation. The second step inside the DI package, I'm going to create a Kotlin file. I'm gonna call it annotation. Why we have created the annotation file? Inside the annotation file, we will create for each implementation its own annotation. So for the first implementation, it will be annotated, or we will name the annotation. It's a custom annotation. We'll name it, for example, the payment first implementation. So in order to do that, we have to add the qualifier annotation. So when using the qualifier annotation, we are allowing Hilt to create a custom qualifier. So afterwards, we will use the retention, and we will do annotation binary. So the retention annotation will indicate to Hilt the annotation is stored in the output, binary output, whether true or false, and visible for reflection, is it true or false. And the annotation that we will do here is going to be stored in the binary output. So annotation retention does binary, and we will create here an annotation class. Let's call it, for example, payment first implementation. So with the same thing, we will name the second annotation for the second implementation. You can name it whatever you like, it doesn't matter. Good. Now let's come back to the app module. And here we have to show Hilt how to provide those dependencies with those new annotations that we have created. So under app module, let's show Hilt how to provide the first one, which is the first implementation. So first of all, I'm going to annotate it with provides, and let's indicate to Hilt, for example, this annotation will be instantiated only once with the help of the use of singleton annotation. And because we want to show Hilt how to provide the first implementation, we're going to use our first payment first implementation annotation. So it's going to be payment first implementation annotation. And here, as we did in the provides products API, we'll write here provides payment first implementation. It will give us a payment repository interface, and it will return simply payment repository first implementation. Sorry, it has to be first implementation with parentheses. All right. With the same thing, we will annotate the second one, which provides the generated component is going to be instantiated only once, and we will use payment second implementation annotation, and provides payment second implementation. It will give us, of course, payments repository, and it will return with the same thing, payment second implementation. Here we go. And that's pretty much it. So I'm going to create here a new model in order not to get confused. So a new class, I'm gonna name it payment view model. I'm gonna copy this one class, and I'm gonna delete it because I have created a shortcut for it. Good. So as dependencies, I will provide here the annotation payment first implementation and private val payment first method. Let's name it payment first method. It's going to be of type payment repository. And the second one with the same thing, payment second implementation private val second method of type repository or payment repository. We have injected payment first method and second method as usual, mutable state flow. Let's name it from first implementation. Second one with the same thing, and going to do as usual init function just for testing purposes. It will be view model scope and launch. We're going to execute the functions independently. So I'm going to do first value or first job. equal async, not assert, async, and inside it's going to be payment first method dot confirm. Second job, instead of first method, it has to be payment second method. All right, then we will do the first implementation dot value equal first value or first job dot await and second job from the second implementation. All right, now we have our main view, our payment view model is ready to go. Let's come back to the main activity. Let's create a new member here. It's going to be private val. I'm going to call it payment view model. Next, let's create the observables. All right, so let's add a divider here, divider, and the iMessage, and the message will be, let's say, for example, the first result, payment 1 and payment 2 with a divider. Let's see the application. So as you have noticed, the first one completed first, which is first implementation, and the second one completed the second, which has 2 seconds as a delay. First one, 1.5 seconds, completed second. So let's talk a little bit about the predefined qualifiers provided by Hilt. For example, in order to access the application context or the activity context as a dependency during injection, we use pre-built qualifiers such as application context or activity context. This will provide for you the needed dependencies. So let's take, for example, this helper class. I'm going to group the helper classes in a package. I'm going to call it helper. So let's assume that we want to retrieve some metadata from a media or an MP3 file. We will need, of course, the context of the application. We can't actually access the context without the qualifier. So in order to do that, of course, I'm going to inject here in Constructor. And inside the Constructor, I will inject the application context. It will be a private val context, not of type application context, but of type context. So this is a predefined qualifier, and here, of course, the rest of implementation. So for the other one, the other predefined qualifiers, for example, the singleton components, for default bindings, it is the application. For the activity retained components, the default binding is the application as well, and so on. So you can see in this table the different Android components and the corresponding default bindings. We have used here in the app module the scope of the dependency. So the default behavior when it comes to scoping bindings in Hilt is that all bindings are unscoped. In other words, Hilt creates the needed instance in demand. For example, every time provides the dependency metadata helper to another class in Constructor or by field injection, a new instance of the metadata helper is created. Sometimes you don't want this kind of behavior, so you need to scope the bindings. So if we change, for example, instead of singleton component, we'll do here, for example, view model component. What does this mean? Generated component will be available for the activity. So the scope is activity retained component. So what does this mean? It means that whenever the view model is alive, we will have the instance available. But if the system or Android destroyed the view model, we won't be able to access the dependency. And the scope for this view model component is view model scoped. So you can see different scope in this table. For example, for the fragment, the generated component is fragment component. So here we have to do fragment component, and the scope is fragment scoped, and so on. So Right now we're going to talk about the dependency injection for unsupported classes, because Hilt won't support every single possibility or single class. Sometimes you are facing some unsupported classes. So how to show Hilt how to inject unsupported classes? So you have to follow steps. Let's assume this class that I'm going to create right now is not supported by Hilt. So inside helper, I'm going to create here a new class and I'm going to call it notifier helper. We'll use inject constructor. As the first step, we have to annotate the portion of the implementation by @entry point. This will tell Hilt which code is the limits of Hilt support. I'm going to add here an annotation, entry point, showing Hilt this is the limits of the Hilt support. So after that, install in, as we have done in the module. Let's choose here singleton component. The interface notifier entry point will be the limit. So let's assume that it has an instance or a dependency. Let's call it Firebase notification, the Firebase notification class. And I'm going to add here inject. It has to be here Firebase notifier. So afterwards, what we have to do, we will create a variable, call it notifier. It will be Firebase notifier. And during the initialization of our notifier helper, we will create a factory in order to allow us to construct the notifier. So we can access the entry point using entry point accessor. Here we're going to use or to access the entry point from the application. So we need, of course, a context. So for the context, it has to be provided as a dependency in our class. So we have already a predefined qualifier for that purpose. It is application context. Let's do here private val context of type context. The context will be context. We will provide here as a second parameter the notifier entry point that we have defined as the limit of the Hilt support. And finally, we will do our notifier equal notification factory, and we will do Firebase notification or Firebase notifier. So this is how to show Hilt how to inject the notifier or a class that's not supported by Hilt. And finally, we can use the notifier in our view model or wherever we want. We can test this by doing here, let's say, for example, function get notification string. It will return simply a text telling you have a notification. You have just received. Let's do a suspending function here and we will delay it with 3 seconds. All right, so main activity inside our main view model or payment view model or whatever you want. Let's inject here the dependency, which is private val notifier helper. I'm going to create here another observable or mutable state flow. I'm going to call it notification, and here another job, third job. Right here we have created notification helper notifier dot get notification, and here we will do notification dot value equal third job. Here it has to be third job, and of course third job dot await. And inside our activity val notification by payment view model dot notification collect as state. Going to duplicate this code here and going to do here notification. Let's test our application to see if everything is working correctly. First implementation, and you have just received a notification. So this is how to deal with injecting unsupported classes using Hilt dependency injection. So what is assisted injection? Assisted injection is a technique that allows us to create an object where some of its dependencies might be provided by Hilt. In other words, Hilt know how to provide those dependencies, and other dependencies must be provided at runtime. So how to do it? Let's take the following example. So I'm going to create another helper. Let's name it, for example, remote metadata. So let's assume that remote metadata has one of its dependencies will be decided in runtime. And the other dependencies, let's say, for example, it will be a local retriever or local metadata service. All right. So the first thing, instead of doing injects constructor, we will do assisted injects. So the annotation assisted injects will indicate that this constructor will be created by the use of assisted injection. Annotation assisted injection can't be scoped. So we can't use here, for example, a scope in our, for example, activity scopes. It's not possible. It's going to give us an error. So the dependencies that we have here in the constructor, let's say we will need an application or a context. So here it will be private val context of type context. So Hilt know how to inject this dependency, as we have seen before. Another dependency that Hilt know how to inject it, which is the API builder, and the dependency that Hilt will inject in runtime will be, for example, the private val retriever. We have to annotate it with assisted. So assisted annotation indicating to Hilt, this is the dependency that will be provided at runtime. So the step number 2, so here it's gonna be, of course, the rest of code. So the second step, we have to create for this remote metadata a factory class. It has to be an interface. So here in the DI package, I'm going to create a new interface. I'm gonna call it, I'm gonna just copy this name, and here I will put remote metadata factory. So the remote metadata factory, it has to be annotated with the annotation assisted factory. So the assisted factory will tell Hilt this interface will allow us to create an instance of the class that we have specified, which is the instance of the remote metadata. All right. So it has only one function. It's called create, of course, and it will have as a parameter retriever of type metadata helper, and it has to give us a remote metadata type. All right. So the question is how to use this mechanism in our context or in our main activity. So let's move back to the main activity. Let's do here, after creating the payments view model, when using the annotation, of course, inject, we will indicate into Hilt we are going to perform field injection. All right. So first of all, we're going to create a variable. Let's name it remote factory. So the remote factory, it's going to be of type remote metadata factory. Afterwards, we will create the retriever of type metadata helper. So private late init var, and keep in mind, if you have added the accessor private here, it's going to give you an error. So you don't have to do a private member. Keep always as a field injection, keep always the members public. So here private late init var, and afterwards I'm going to call it retriever of type metadata helper. I need, of course, a remote retriever in order to access my remote retriever. So private late init var remote retriever. So inside the main activity class, we have to create a private function. It's going to be the getter of our remote retriever. So private function get remote retriever to instantiate the class or the member remote retriever. So here we will do remote retriever member equal remote retriever factory dot create. Now we are creating the instance, and the retriever will be the retriever that we have created, which is the helper metadata helper. And now we can access the remote metadata retriever. So let's run a test on this class. Let's say, for example, here function get remote metadata type string. Let's delay this with 4.5, and let's return remote metadata data from API. So to test our application, I'm going just to get rid of this function. I don't need it actually. I have to inject here the retriever. So inject retriever, and I have to get rid of the private accessor. And now after notification, I'm going to do here launched effect. Here I'm going to add another parameter or a value. I'm gonna call it metadata equal empty string, and gonna do here metadata. And first of all, I'm going to construct the remote retriever. Afterwards, I will execute the function. So metadata equal remote retriever, and I will do get metadata, which is a suspending function. Here I have to do here var. I'm going to show a toast, for example. So toast dot make text. For the context, it is application context. For the text that I want to show, it is metadata, and for the duration of the toast, it's gonna be short, and I'm gonna hit show. All right, so let's test our application. So the previous result will be as usual. And of course, after 4 seconds and a half, we have remote metadata from API. So this is how basically to deal with dependency injection. You have seen manual dependency injection. You have seen the inconvenience of using manual dependency injection. And we have used Hilt to solve that problem. So you have seen pretty much almost every scenario that we can think about in our project. If I have missed something, you can leave a comment in the comment section below. And I hope you liked the video. See you in the next one, and bye-bye.